Okay, this is the fourth video segment for homework number 9. So I'm gonna do these two word problems here. It says that we have a rain gutter which is made from a metal sheet. So presumably it was a flat metal sheet like this, and then we bent the sides of it. I mean, two lines along the edge, so it became like this. Okay. So we bent it along these two lines, and there's a drawing here. And let's see what else it says. Okay, so okay, these edges are 10 centimeters each. So when we did this, I guess this was 10 centimeters, and this was 10 centimeters, and this is 10 centimeters. They're all equal in length, like this. They're all equally divided like that. These are all 10 centimeters each. And we bent it by an angle that, of course, we don't know what it is. And it says that, first of all, show that the area is given by that expression. Now, let me see. Now, the situation that we have is something like this. If you look at the side view, this is 10, this is 10, and this is 10. And there is an angle which we don't know what it is, but I know that these are equal. Okay, and we are supposed to find the area. Now, the area of this piece, okay, if you look at the area of this particular side, like this, uh, there's different ways of doing this problem, but one of them is to do it like so. See now, this area is the same as that area. So what I need is two of these areas, these triangles, plus the area of this rectangle. Okay, first of all, the area of that rectangle is uh, this height. If you look at this right triangle, this angle is theta, this angle is theta. So is this height is 10 sine theta. Okay, and if you wonder why, let me redraw it here. You draw it here. Uh, this was 10, right? This angle is theta. I have no idea what this thing is. I'll call it x, okay? So the ratio of x over 10 is actually sine of theta. So x is equal to 10 sine theta. This is really what I wrote down here, okay? So if you look at, all right, if you look at this rectangle, the area of it will be the height times the width, which is 10 times 10 sine of theta. This is the width, this is the height. And the area of these side triangles, like this one, or the same as that, is two of them. There's two of them, and each one is 1/2 times the area of the height. The height is 10 sine of theta. This is the height, right? This is the height. Times the base. And the base is, let's think about it. The base is this much or that much, which is actually 10 cos theta, okay, times 10 cos theta. So the area is equal to 100 sine of theta plus, you multiply these together, 100 sine theta cos theta, because the two here and two there cancel. And that's exactly what we got in the statement of the problem. Okay, then it says graph this thing for theta between 0 and pi over 2. Okay, so let's go to our TI 84. So first of all, let me make sure that the mode is on radian. I believe it is in degrees. Last time I did this, see that it is on degrees. So let's scroll down here. Now it's in radian. Very good. So now we're going to go and put that function in there. So it's going to be 100 times, it was sine of theta, right? Sine, can I type here? No. 100 times sine is right there. Okay. Sine of theta, I think that's where it goes, right? Yeah, sine of theta. Sine of the variable, there's the variable. And then plus 100. Oops. Oh, I don't know how the backspace is on this. 100, I'm really sorry. Sine of 100 times, where's the sine? Sine of x, close it, plus 100 times sine of x, oops, uh, of x. I don't think you can backspace here. That's what it is. Close it, times cosine of x, close it. Okay, so that's the function. Now I'm going to define the range x going between 0 and pi over 2. So where is the window? X is going to be 0, pi over 2. Now pi over 2 is about, okay, 3.14 divided by 2, 1.517. 1.517. So x 1.517. Is that right? Yeah, 3 point. I don't know. Let's see. Pi over 2. Let's do that. Calculated. 3.1415 divided by 2, 1.57. So that's not right. 1.57. Now I don't know what the y scale is. We just leave it the way it is and we're going to graph it. Okay, so we should have actually our window size changed here. Let's go back there. Window. X goes from 0 to 1.57. Y, let's make the minimum y to be 0. And for maximum, I'll make it, for now, I'll make it 100. Graph it. Yeah, so I should have a better idea of what the height is. So let me see now. Uh, Obviously the area goes from 0 and so let me change the height to be maybe, I have a problem with my window here. So let me see now. That's okay. Uh, Let me check my mode again. The mode is radian, which is good. So it's the window size. The window size going from 0 to 1.57. Okay, I think this scale, I want to change that. I'm going to go scale of 0.1. Okay, so let's try now. Oh, that's better. You can see that the scale here is zero point 0.1, but this height I should choose it to be bigger. So for let's see now, um, window. I'll make this thing 200 graph. This is good. Okay, so just a word of caution. Graphing is an iterative process. You have to do it until you're happy. Okay. So first of all, we did graph it between 0 and whatever we were asked to do. And then it says for what value of angle, for what theta is the biggest area can be achieved. So you can see that if you look at these things, these are each point 0.1. Remember I changed the scale to point 0.1. Point 0.1, point 0.2, point 0.3, point 0.4, point 0.5, 6, 7, 8, 9, 10. Approximately this point is 1. This is 1. 10 of these subdivisions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I made these subdivisions 0.1. Remember I changed the X scale. So this where the thing is maximum is about 1. 1 radian. So the answer here is, let me add some paper here. Okay. Based on graph, theta approximately 1 radians. Now, 1 radian, remember, approximately, if you want to get it in degrees, you multiply it by 180 divided by pi, and this is approximately, let's do that. Let me see. So we have 180 divided by pi, and you get approximately 57 degrees. So the bending here must be done at approximately 57 degrees to get the maximum area, which is this area. And obviously, that's going to collect the maximum amount of water. All right, so let's go ahead and do the next one. The next word problem. Okay, I'll add the paper here, add the page. Oh, why it keeps adding to the top of the page? That I'm not sure. Okay, so this is a kind of thing that you do in a physics class, but it's called a trajectory problem. It says that if you throw a rock here, uh, okay, so if you throw a projectile here, assuming there is no air resistance and complication of that type, this is going to go at an angle. If you throw it at an angle, it's going to go up to maximum height, and then it's going to come down and hit the ground again. The values of R and G are calculated here from a physics course, and it says, okay, if we know the acceleration of gravity, acceleration due to gravity on Earth is G equal to 32.2 feet per second square. Okay, this is on Earth, and on the Moon it's less. That's why you feel weightlessness up there. Uh, feet per second squared. Find the range and the height. The range and the height formula is given, so let's do that. Let's do that. Suppose theta is equal to pi over 6 on the Earth. It's going to be range is going to be velocities 12 squared times sine of 2 times pi over 6 divided by 32.2. This is on Earth. So this is 144. Now sine of pi over 3 times 2. This is pi over 3. So it's going to be root 3 over 2 divided by 32 over 2. And b on this is for the range, and the height. Let me do the height for you. Height equal to 144 or 12 squared times sine squared. So sine of pi over 6. This is squared because the power is on top of sine, divided by 2 times 32.2. So this is going to be 144. Sine of pi over 6 is 1/2. You square it, get 1/4, divided by 2 times 32.2. Let me go ahead and do these things. I'm going to put this thing in my calculator, my phone. So let me see now. 144 times. Actually, I'm going to use actually sine of, times root 3. Okay. And then divided by 2, divided by 32.2. So for this number, I get 3, unless I made a mistake. I get 3. I think my pen died here. So let me see for a second. It looks like this program's interfering with my Word for some reason. Yeah, I think my Word document died. Now for the range, I'm sorry, I can't write it down here. My pen is not working. So for the range, I get 3.87 feet. I don't know why I put down 32.2. It should have been 32, but that's fine. Okay, and for the height, I don't like this number because this number is too small. But well, what can I do? That's what it is. Oh, but the angle is high. The angle is 30 degrees, so maybe that's why. Okay, so anyway, I'll let you work this out. For the height, let me do the height. Let's hope that I didn't make a mistake here. 12 squared, that's correct. Everything looks okay. Range, I'm getting what I just told you. Okay, let me do the height. The height is going to be 144 divided by divided by 8 divided by 32. I use 0.2, but that's okay. For the height, I get half a foot. Oh, I don't like those numbers. These don't make sense. Okay, but that's what it is. Based on these formulas, this is what I get. I may want to check my physics book to see actually these are correct or not. But right, okay. I'm gonna stop this thing here. I'm not gonna do the one for the moon.